All right, test one down. We're getting ready to start working on stuff for the second test. The first thing, that's pretty. The first thing we worked on was arrays, and you understand the concept of arrays. And what I'm showing you right now is something I put on D2L, and this is for you to practice. We're not doing everything hands-on in class. We got enough to do with vectors today because that's a new concept. But if I'm taking a look at this, I see a program that will convert, or that is matrix stuff in Java. Can you write the two-dimensional array and how all of that works in C++? Again, this is where we officially ended 121. The last thing you should have covered, and if not, go complain to your 121 teacher, was two-dimensional arrays. So if I look at this program, go download it real quick, and pull it up. This video should be me. At least it looks a little better. And if I go and pull it up, what was that called? Matrix stuff. And it's opening up. And now I share again. And it's not showing. So if I share, I apologize, the screen. And what's going on here? Well, I have a method. Remember, Java is methods down here, starting where it says methods. I'm going to fill my array. Okay, if I come back up to the top, line 18, 19, and 20, I'm declaring three arrays, matrix A, matrix B, and matrix sum. These are all size 3 by 3. I'm calling a method called fill. I'm calling it on matrix A. I'm calling it on matrix B. I'm reusing methods. I have a method print I'm reusing. Same concept. If I want to print A, I want to print B. I have a method called add matrix. These are all void. I have a print method. Now in C++, we use functions. First method, fill the array, 0 to 3, 0. I'm using nested for loops. Random numbers from 0 to 9. And when I add 1, it's going to give me the numbers 1 to 10. I'm going to print the matrices. I'm going to do a little formatting to make them look nice. I'm going to add the matrices. Same thing, I keep reusing these nested for loops. Seeing the solution is kind of not bad. I'm okay with that. But you, in my opinion, should want to converting it over to C++. One thing to make note is when I'm working with a two-dimensional array, and now in C++, this is a function, I can throw a word constant in front. What's constant do? Pretty?
Makes the a variable unchangeable.
Yeah, it locks it down. And you notice when I am passing, instead of two sets of square brackets, I need to include a size in that second one. This is C++ requirement. I have to throw that in. So if you are working on becoming a better programmer and you want to change that two-dimensional array program where you add it, yada, 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 this is one thing that you have to make sure you remember. I have to include a size there. Same kind of thing. Nested for loops going on in here. So that would be good practice. I don't think it's worthy of class time, but I am strongly recommending it. Another program we used to do that we did in 121 was, and I have a whole bunch of stuff thrown out here. What if I said I'd like you to play the game of tic-tac-toe? And each one of these has a location. It's a 2 by 2 dimensional array. There are 9 spots. I want to put in X's and O's. Instead of working with 0, 0, maybe I'd work with 1 to 1 and ignore all of the 0 subscripts. How would you go playing tic tac toe? Well, I would sort of create an algorithm to go with it. Initialize the board. What do I want the board to start out as? Well, I don't want X's and I don't want O's. I want something in there so that I know it's not an X and O. Could use a blank, something. Could use asterisks. That way, if I print the screen, I know those spots are empty. Something. Display the board. Well, we saw something like that in Matrix. We're going to start out. X gets the first move. And there's some stuff that got added later. I need to keep going until I find a winner. If I don't have a winner, I keep going. And if I haven't run out of moves. So I need to count for the number of moves because there's 9 moves. What happens if my count gets to 9? I have a tie. I have a tie. Yeah, that's going to be down here on the bottom. If I come out of here, if count equals 9, then I'm going to display a 9. But I need to get a move. I need to go somewhere where it's blank. I have my board and I have the move. Maybe the user could pick numbers 1 to 9 for their move. Maybe you could say, what row, what column? Display the board. Check to see if there's a winner. If the move was X, the move now becomes Y. Otherwise, the move becomes X. Increment counter. So this was 20 minutes of class scribble to write this down. But if I gave you this, you'd be like, okay, yeah, I have a couple of functions to write. Initialize the board, display the board, get the move. Oh, there's display board being reused. Check winner. I should have made that your assignment for this week. Tic tac toe. Questions on working with two-dimensional arrays. While we're still on the topic of arrays, do you remember what the big 3 were? How do I, right here's the big 3, line 11. How do I write the prototype? This is an integer, two-dimensional array. I'm passing an integer. I'm just letting you know what I'm going to be working with. The second one was how I pass it. How do I pass it? I just pass it by the address. This is the address. What's at the address? It's an integer array of size I don't know by 3. This was the third big one. This was the second big one. And last class, when we were working with arrays, everybody was stuck until I said, hey, go to 17 dash, I don't remember what number it was, 7-17 maybe, and use that code listing. And it was like, oh, yeah, that's the stuff we need. So don't forget about that. Any more questions on arrays? Cool. Code listings we had. Yeah, three-dimensional array. When I was in high school, I used to have taught 4 school years of comp sci. And they had to come up with a final project. One of my students' final project was three-dimensional tic-tac-toe. Yeah, row, column, and height. And how many ways do you have to check? Well, on a regular tic-tac-toe board, how many ways do you have to check to see if there's a winner?
3.
3 horizontal, 3 verticals, and 2 diagonals. So it sounds like about 8 ways if you were 2-dimension. Now you have to figure out how many ways would it be if it was 3-dimensional. Boy, I know, right? Think about it. We can't have more than two dimensions. Okay. Today we're going to get into these things called vectors. And oh my goodness, cheese crackers, boom. I got all kind of stuff highlighted when I read through this. I write all over the place. I'm the half-blood prince, right? I have all my notes inside of here. But the first thing that I have written in there is the word dynamic. So I'm going to come in and start with my notes, and I am recording. And what's a vector? So when I first started teaching in high school, there was this data type that came out. It's going to blow your minds. The data type was called string. And we're going to talk a little bit more about it in this class because we're going to talk about something called C strings. Well, when computer languages were first written, we had an array of characters. That's how we worked with a string. We had an array of characters. And somewhere along the line, Bjorn Stroustrup, however you say his name, decided he's going to make a class. Not the math class. We know what the math class is. It's a whole bunch of functions written for us to use. Well, they created a class called string. And to go with string, we have all of these functions. Now it's secondhand because it is one of the most popular data types we use. So in this library, this class was created. Well, in this library, we have a new data type called a vector. A vector is an idea similar to an array, but in order to work with it, I have to have a bunch of functions. Okay, kind of got an idea what he's saying, I hope. So I have some stuff written down here. It's stored in this place called the Standard Template Library. And the question is, well, if we have arrays, why do we need this thing called a vector? Well, a vector is, in fact, what we call dynamic. An array is static. And what I mean by that is, how many items do you want to store in your array? 12. Okay. I'm going to make an array of size 12. How many can I work with? 0 to 12. What if I wanted 14? I'm stuck. My memory is static. I can only use so many locations. Static is a key word. Right? Vectors are a little bit different. A vector is what we call dynamic. And what I mean by that is it can grow or shrink. Now, if I come up here, what is this right here? Actually, right there. What is that right there in the beginning? we'll,
Zero.
see, we'll see, Tanner. That is array, R, and that is a memory location. This guy is array sub zero. This says move over 0 times the size of the data type. Moving over 0 times 4 bytes. Takes up 4 bytes. This guy will then move over another 4 bytes. Array sub 1 is 1 times 4. So it goes to this address and moves over 4 bytes. Moves over 8 bytes, 12 bytes. And these guys are side by side. And done. Could I do array sub 13? Trick question. Java, no. C++, yes. I won't get an error. I won't get an error, but I don't know what I'm getting out of there either. That's just going to be whatever's in storage. It's kind of goofy. It's whatever is over here. So today we're going to look at a vector and it's dynamic. And for this vector, I need functions that work with it. And in a skinny, I'm going to have an address to start, and then I'm going to put something that's 4 bytes. And then, if these are integers, and then something that's 4 bytes and 4 bytes. Oh, and I'm going to use this. So I just eliminate those 4 bytes. It's gone. I need another 4 bytes. I just keep taking side by side by side in memory. Well, how does this work? Well, we have a vector. It's like an array, except it's unlimited in size. How do I declare it? I need a preprocessor directive. I have an include statement. Okay, let's see what's going on in here. For my vector, again, it's like an array, holds a sequence of values, stores them side by side in memory, and I can even use a subscript. Oh, how's it differ? You don't have to declare a size. It'll increase as long as you want. You can still find the size. All right, my preprocessor directives. Bing, bang, boom. Ah, this one says, hey, I want to use a vector called numbers. Thumbs up, thumbs up. This one says, I want to use a vector called numbers, and I want to reserve the first, I want to reserve the first 40 bytes. I know I'm going to need at least 40. Might need more than that. That's the advantage of a vector. Might need less, but I want to reserve at least the first 10. I want a vector number, yeah, but I want to fill them. This is kind of cool. I want to fill them all with twos. So we have a bunch of different ways of defining a vector to get us up and running. Questions? This is my declaration section, what I want with vectors. Staying with vectors, I can do some implicit initialization. I want to declare a vector. It's called numbers. It's going to store integers, and I want to fill the first 4. As I mentioned before, if we declare a size, we can use square brackets. Otherwise, not. Okay. Coming over, and I'm going to use some stuff from the book, hitting highlights of the vector classroom lecture that was available for you to watch before class. But we're going to run through the code listings and see if you have questions. Okay. Line 12 and line 13. I'm declaring 2 vectors. I'm giving them sizes. So that means if I wanted to, I could use square brackets. Okay. Like I said, there are similarities between a vector and an array. To me, this is like, why not just use an array? When I use square brackets, I fill them that way. So it's quite similar to start. Code listing 727. All right, I want to fill an array. It's empty. It's called hours. I have another one called pay rate. And again, I write in my book, these are all empty. These are nothing. So this means I'm going to be able to start and just keep adding and adding and adding as long as I need. Now, how do I add when I don't have the subscripts? Well, this gets into our first function that we are going to get from the class in that standard template library. And it says, take the vector name and do this function, push back, and it's going to store temp hours. It added to the hours vector. Here I'm adding to the pay rate vector. Okay, so I'm pushing them. That's a key word, push. So keep that in mind. So that's my first, yay, I like it. Another function. If I take the name of the vector, whatever it is, in this case, vect, I can find out what the size of the vector is. That's my second function, right? Size of the vector. Okay. 728. Let's see. I am filling a vector with a whole bunch of items. Okay. Here's a prototype. prototype. This is one usage. Here's the second use when I call show values. And again, I'm passing the address like we did with arrays. And then finally, here's how it is. I create a local variable, a vector of integers to work with. So that was that third step. Listing 729. I got notes on the side. I got notes. This guy is something along the lines of what we call a stack. A stack. And it follows this idea of the last one in to the vector is going to be the first one out. We cover stacks in depth in 162. A stack, which is LIFO, and a queue. Grocery store line in England is a queue. The first one in is the first one out. But this has a stack. And the reason the word push comes in is we push a value onto the stack. We push a second value. We push a third value. We push a fourth value on this stack, the stack of plates. Okay. Then when I go to get the first one, I'm going to use a function called pop back. That's going to take that one off the top. So 729, I push one, boom, one's down here in the bottom. I push two, two is a little bit on top of that. I push three. Now when I come down here, I pop. And when I pop, it's going to take that three out of there. Okay. The last one in is going to be the first one out. And we have something called pop. What if I have a vector and I don't know what's in it and I want to get ready to use it? Here's another function. Clear. Clear. Oh, that's not right. Clear. Okay. Lots of different things going on in these code listings, and they're all good to have. An example, here's another function. This is what I was looking for. I have them highlighted, so it makes it easy for me to find it. What if my vector is empty? Okay, then yeah, oh, this is sort of like what we just did with finding the average. If it's empty, yeah, there's nothing. Otherwise, I can actually do that division, find out what the average is. I think we had one size that we could have used to see how many elements or items there were. Okay, so I have this whole clear, empty, pop, push, resize, swap. There's some other things going on. These are the big four. These are the big two, pop and push. Okay, questions? Questions? Again, this idea of a vector is important because it carries over to 162 to a data type that you're going to go, yeah, I got it, I got it. Where are my notes here? What are we doing next? You wrote a program and submitted it to me called Fibonacci. Okay, Fibonacci. In your group, the first thing I want you to do is make sure you can get a vector program up and running. You already have the concepts done for Fibonacci. You're just basically converting this from an array program to a vector program. Do not use square brackets. That would make it really easy, right? That would make it pretty easy. We don't know how many terms they'd like to see. They say 10, we start, fill the first one, fill the second one, and keep pushing and pushing and pushing till we get to a count of 10. Do not use square brackets. That's too much like an array. If you get that done, and you probably should, Then go back and rewrite that Java, that program to add matrices. It's good practice for the two-dimensional array. So really, I should be rewriting this as do that second and do this first. Questions? Yeah, what do we got up here? Some functions. Again, value located at, oh, there it is. That's the first one. We have a dot at function. Returns true if empty. Well, yeah, that's dot empty. Removes the last one. Pop. Last in is the first out. Gets the number of items size. This is like a little connect the dot game. Clears all elements. That's easy. That's clear. Adds to the end. That's pushback. Pushback, pop back. Pushing a value. What you think? All good?